We got 2 minutes still. I'm not starting until 11:10. Gosh darn it. I'm going to do this at the appropriate time. All right, it's about time to get going. I'm Mark Woodard. I'm taking over for Dr. Godrich for the next couple of class periods up until Monday, I believe. It depends when he gets back. He's having a baby, so give the guy a break, right? I'm going to pass around an attendance sheet just to take attendance. Just write your name down on here so I can make sure that you're here. Report back on that. Pass it around in whatever fashion you see fit. So I'm going to be taking over today. We're going to be learning a little bit about Python, input, out, numbers and variables, interaction with the shell, scripting, all sorts of good stuff today. It's going to be awesome. But let's start just with the Scratch stuff we've already been working on. You guys know that that assignment is due at 5 today. That's 5 o'clock p.m. today, I believe, to Moodle. And we're doing that. Everyone doing okay project? Any questions? I would like to hear them now so we can talk about them. The curvy lines especially are the real trickster of this assignment. Everyone doing all right? Well, this is just no questions at all. Yeah, anytime throughout class today, like today's going to be very much an experimentation day. We're going to be feeling around Python. We're going to be playing around with it. So at any time during the class, just like raise your hand, be like, I don't understand what's going on here. Why does Python do this? That sort of question. Please just stop me and we'll go with that. So if we don't have any questions on Scratch, go away. Updates 4 hours. Then we can get on to Python. Yeah? All right. Can everyone hear me in the back, by the way? I sometimes have a problem. Okay. You can see on the screen. We're good. So, Python. Has everyone downloaded Python 3.4 idle? You can open it up. If you type in something like idle, you click on it, and then you get a screen like this. This is what we're going to be working with today. So if you don't have this, you should get it, because if you don't, you're going to be sorely missing out today. But we'll be going over that. So let's start here by thinking about an equation. So let's say we have something like x equals a plus b times a times b, or a plus b times c all over d. My handwriting's terrible, but I just made up this equation, but let's say something like that. And we have to do it a bunch. We know we're going to have to solve for different variables in this equation all the time. We're going to do it over and over again. So we could do this by hand. We could say, okay, what does A equal? What does B equal? What does C equal? And what does D equal? And then we could fill them out, 2, 1, 3. And we could fill them all out, and then we could plug them into the equation, and we could do all the math and figure it out, right? But we're computer scientists here, people. We're trying to do it a little bit faster than all this. So today, we're going to be learning Python to try and expedite this process, to try and figure out, okay, how can we take input in from a user, and how can we use a programming language like Python to do equations like this? And how do we even communicate with the computer to talk about a formula like this? How do we make a computer math? And we looked at that a little bit in Scratch, right? We saw in Scratch, they had those little math pods. You had your, operators where you could do all of your math, and you had data where you could make variables, where you could imagine storing things like this. And you could actually imagine writing something in Scratch that could do something similar to this, although it doesn't really have anything to do with movement, but you could imagine creating 5 variables, X, A, B, C, and D, and then doing that equation over there. And it should be pretty straightforward, right? So today, let's go over Python and how we're going to do it in there. Because Python is the language we're going to be using for the rest of this class. So we're going to want to get familiar with it before we get too deep. So everyone should open up the shell. We're going to be playing around with the shell here. So let's start off with just what exactly Python is. Python is a dynamically typed, object-oriented language. Okay, those are 2 words that you don't need to remember, but they're very important. Especially the dynamically typing, you don't need to know. But the object orientation of this language is very important. It means that everything in this language is an object, and we'll be getting to that and what that means in just a second. So this is the shell of Python, how we open it here. You might have seen programs written in the past where they're written line by line, where you would write one line and then after the next line, after the next line. This is a little bit different here, what we're doing in the shell. That other way of programming is called scripting, and this is a shell interaction. What we can do with this is we can type in one command into the shell, and Python will respond to it. We put in one line, and Python responds back with whatever it responds. So the basic loop of the shell is we tell the shell something, it evaluates whatever we're trying to say, it will print back a response to us, and then it's going to loop and ask us to put in something else. So let's get into what we can do and what we can't do. Let's just start off by trying to put stuff into the shell. Someone tell me something to put in, and we'll put it up there. Raise your hands or blur it out, whatever needs to happen. What should I type in? Anything.
Import anti-gravity.
Import anti-gravity. There we go. Very, very neat little trick of Python. So it actually, that's a funny special case of import where it'll actually pull up a website of a funny XKCD comic of importing gravity in Python. But that's really a special case. Import is something you can do. You can do things like importing things like math. And this allows you to do extra stuff that Python isn't usually able to do. Give me something else to type in. We'll talk more about imports later.
Hello world.
So print hello world like that.
You can put us in the string.
Print hello world. Syntax error. All right.
You need to put quotation marks.
Ahaha. We have a smarty. Print hello world. And finally, we get our red text to go away, and it's going to work. So what's the difference between this statement here and this statement here? Someone go ahead and point out the obvious answer, please.
Quotations.
The quotation marks, right? This one we print hello world, and this one we say print quotation marks hello world. And you'll see the hello world actually turns green in our shell here. This denotes that we're dealing with something completely different. When we say hello world here and hello world here, we're saying something completely different, and Python interprets that completely different. And this goes into how Python is an object-oriented language. Everything you type into Python is an object. So when we try and type hello world here, it's seeing two separate objects, hello and world. When we type in hello world here with the quotation marks around it, these quotation marks actually put that hello world together into one object that Python knows as a string. You might have heard the word string before. We're going to be going over a few basic types of objects in Python here today. Words, numbers, and variables. Oh my gosh. Okay. Words, numbers, and variables. When we're talking about words, we're talking about strings. Python understands words through a type called strings. And just to clarify, when I'm talking about these objects here, like the object hello world, that object has a type associated with it. And that type is what we would say is a string. Like that object hello world is a string. Its type is string. Numbers have types like int and float. And variables are a special object that stores state. So when I'm talking about objects and types, this is what I'm talking about. Talking about strings, ints, and floats. Well, let's just start with string. They're sort of the most simple example of an object, although they do have their quirks. So the straightforward example of a string is just one word in quotation marks. Hello. And if you type that into your shell, it just responds back to you, hello. It sees you put in a string, and then it just shows the string back. It's like, oh, you gave me a string. Here's your string. And it prints it back. Strings also work with single quotes. And there's some other semantics here. Let's try just putting some stuff in. Somebody give me some words to type in, and we'll see what Python does with them. And let's try in particular to break this thing. How would we get an error out of this? What words or characters do you think we can put in here to break the thing?
An equal sign.
Equal sign. All right. So equals. Not quite. Let's try again. At symbol. So at. No, we didn't get it that time. Let's keep going. Backslash. So this one or the other one? Ah, we got it. We finally broke it. We put, sorry, you guys can't actually see quite to the bottom here. We finally broke it. So when we put in the backslash in these quotation marks here, Python didn't know what to do with it. It gave us an EOL while scanning string literal. I don't think anyone really knows what all of that means, but basically there's a problem here. And the problem is that some characters, when you type them in, are special. this backslash in particular is a special character that Python uses to escape things. It's the character that you use to do things like typing in, this is a quote. And then it shows the quotation marks here. So when I put this backslash character before another character, it's saying, Python, ignore this one letter. And there's a lot of other weird things that escape characters do. But that's why I didn't understand what was going on here, because we were saying, okay, start the string with this quotation mark, and then we want to escape this quotation mark, but then we don't have a closing quotation mark after it, because this one doesn't count, because it got escaped by the backslash, if that makes any sense. Right? So that's what escape characters do. You can also just break it by using the same type of quotes that you have on the outside. Like, hey, there's a dog. I spelled there's wrong. Anyway. It gets confused, right? Because you say, starting a string right here, Python. Okay, we're going through and we're creating this string. And then, oh, we're ending the string here? Okay. But then what's all this stuff afterwards? Python doesn't know what to do with all the stuff after the first quote. So in that situation, you can use the escape character to do it, or you can just use the other type of quotes. Hey, there's a dog. And if you use the other type of quotes, you'll be dandy to go there. If you need to use both type of quotes, you can do that too. Hey, Bob said there's a dog. I'm terrible at spelling. Don't judge me. 1, 2, 3. Cool. So if you put triple quotes around the whole thing, it's just going to say, it's just going to be like, everything inside here is cool. Triple quotes are like the safest type of string that you can. There's also a few other special characters that you'll need to know. /n is the new line character. It doesn't do what it's supposed to right now because we aren't printing, but we'll see what that does later. /tab character, and we've already talked about the escape character. So you need to know some special stuff about strings there. So this is the first object, the first type that Python understands, strings. You can give it these things in quotes, and it will understand you. It'll know, okay, we're talking about English letters here. Python will understand what you're talking about. Next up, let's talk about numbers. It's math time. Someone give me some math to type in. Let's do some math. I'm going to pick someone. You, give me a math equation. 2 plus 2. Classic. 2 plus 2. Finally, something simple that Python just gets. When you type in numbers and the stuff, it just understands what you're talking about. 2 plus 2, and it responds back 4. The right answer. Let's do some more. And once again, we're trying to keep pushing this system to its limit. Let's put in some equations and maybe try and break this thing. So someone give me some more stuff to type in. You in the black. Give me some.
71 divided by 2.
And we get it. It even gives us back a decimal answer. How fancy. We'll do one more. Yeah. Yep.
71, 2 forward slashes divided by 2.
You're a clever one. So this one did something a little bit different there. So one gave us 35.5 and the other one gave us 35. The difference here slashes. Obviously, these both mean different things to Python. One is your standard sort of division, and the other is called integer division. It divides out the stuff and gives you an integer answer back, meaning no decimals, only whole numbers. It just takes that remainder, the 0.5, and throws it away. Only whole numbers. So that's that. But let's talk about. Yes. Here's something that doesn't work. 7 divided by 2. Now, can someone tell me why this didn't work? Yeah.
It's just printed out the number, printed out what you said.
Yeah, it's just printing out what I said. But what is Python thinking I typed in here? Right, exactly. It thinks I typed in a string, so it gives me back a string because it's inside of the quotes. When I type in numbers, it knows they're numbers, and it knows to give me back a number, right? So it's very important to understand what types you're using and understand that you can't just do math inside of stuff. We'll talk about how you can get math into strings a little bit later. Okay, order of operations works like you'd expect it to. 2 plus 4 times 2, you get 10, right? It does the multiplication first and then the addition, order of operations. If you want to switch up the order of operations, you can add parentheses to your statement. And it will do it the way like that. So math works really well. Math is something that Python gets. Like, yeah, we're good to go with math and everything there. But we've got to be careful with the two different types of numbers we use when we're talking about math. When I talk about the number 2, I'm talking about an integer value. And when I talk about the number 2.5, I'm talking about a decimal value or a float. Over there, I talked about ints and floats. These are two different types in Python, and Python sees them differently. Okay? It may seem sort of trivial because for the most part, Python just understands that you can add them together, you can divide them by each other, and all that stuff. It understands all that. But there are some times when these types break down and it doesn't know what to do with these types. Like the integer division stuff we were doing earlier. We wanted to get back a float, but we gave it the integer division to give us back an int. These are two very different types. You can always check the type of the thing that you're working with by using the type keyword and then in parentheses putting in what you're using, and it will do what the class is. Class and type are sort of interchangeable words here. So like if I type in type of string 12, it'll give me back stir or string. Type of 2, and that's going to be an int, right? So it'll tell you what type you're working with. You can also convert values between these types. So say I want to get, so say I have a float 2.5 here, or even better, the equation or the formula 2 plus 2.5, right? And it gives me back 4.5. But I want to use this as a string. I want to use it in a word somewhere. I can say stir 2 plus 2.5, and it gives me back the string version of this float, right? So now I could say something like 2 plus 2.5 plus this is a number that is now So I converted this 2 plus 2.5 to a string. And then I added another string to the end of it. Python sort of intuitively knows what to do when you give it this plus sign. Because usually the plus sign implies that you're doing some math here, right? But we definitely aren't doing math here. I mean, we're doing math in here, but we're not doing math on the other side. What we're doing with that plus sign is we're taking two strings and we're putting them together. We're taking that string 4.5 and adding on another string after it, right? And then it combines them together with this plus sign and gives us 4.5 string. It's called string concatenation. Pretty dang handy. And you can do it with all the strings you'd expect. Notice it's not going to put any spaces or formatting in for you, though. So you have to do like, hey, space plus there. And then you get the space in there. It puts in the characters exactly as you put them in there. All right. So I'm moving a little fast. Any questions on strings, numbers, math, that sort of thing? Yes. Yes. So not usually. Like if you try and tell it like square root, for example, you might think of something like square root of 4, right? It doesn't know what that is. But we were talking earlier about that import math business. You can tell Python, hey, I'm using more advanced math here. And then you can do things like math dot square root of 4. And it does it for you. We'll be talking more about import statements later, but there are some things like integration stuff that Python doesn't understand out of the box, but you just have to import special, what they're called, libraries to do that stuff. And we'll be talking more about that tomorrow when we go into that. Any other questions? And by the way, anytime during this, if you're kind of wondering like, can Python do this? Just like, we'll throw it up here and try it, and then we'll talk about it. It's great to just play around and just try stuff, and it breaks, but you're always going to learn something when it breaks. Okay, so now, next up, variables. You've all taken algebra, I assume? Yeah, so you know what a variable is, right? It's something that takes the place of something else, right? So we can do variables in Python, and just like we sort of did in Scratch. We do that with the equals operator. We say x equals 4. Notice it doesn't give us back anything. It doesn't print anything back to us, because all that's happening here is it's inside of the computer. It's just assigning this letter x to some number, right? There's nothing to print out here. We can also say things like name equals Mark, or favorite color equals blue, that sort of thing. Now, like, yeah, you're probably wondering, like, so X, name, favorite color, wasn't Python earlier just confused about words and things? Like, why don't I have to make this a string? Why doesn't this have to be a string if it's just some characters? It's kind of interesting. And Python just sort of knows that you're something here because it's one solid block of text. But there are a lot of rules here that you can't break in terms of what name you use for your variables. The classic example is this. what to do here. I forgot the second quote, but it broke before that. It doesn't know what to do because I put a space in between favorite and color. So you can't put spaces in your variable names. Let's try some other stuff and see what other variable names don't work for us. Someone give me some other strange, odd characters to put in here. Yeah.
Type in a string blue and then equals favorite color, all one word.
Like this. Favorite color, like that. Yeah, it doesn't know what to do this way either. So you have to put your variable on the left side, or it doesn't know what to do. Here, Python thinks you're trying to say, all right, see this string blue? It actually equals this variable over here. And Python's like, what? Blue does not equal this thing over here. That doesn't make any sense. That's like trying to say 2 equals 4 to a mathematician. It does not compute to them, and this does not compute to Python. There's just a lot of other characters that you can't use in your variables, like equals 5. It doesn't know what to do with stuff like that. And you can kind of experiment around with different stuff, but basically you want your names to be simple and one word, and that's going to work for you just fine. The sort of standard Python formatting is to say something like favorite color equals blue. Python really likes to use these underscores to separate words in your variable names. So you can do that. Or you can just keep it to like a few letters, FC equals blue, that sort of thing. Keep in mind here that descriptive variable names are really important, just like they are in math. Like if your variable name doesn't mean anything to the person looking at it, no one's going to be able to look at your code. You're probably not even going to be able to look at your code and know what you're talking about. Like if I said equals blue, and then someone looks at the variable alstic, they're gonna be like, what does this mean? What does this mean? It's much better to give the descriptive name, and me and Dr. Goders are gonna be expecting that definitely. Much better, much cleaner. Anyway, so you can assign things to variables. You can assign ints, floats, strings, whatever you want to a variable. They store that in memory. And then when you call it back, like I assigned x a long time ago, when you just type x, it gives you the value that you assigned to it back. So when I type in favorite color, okay, it gives me back blue. And when I type in x, it gives me that. Just like in math, you can use these variables anywhere that you could use the other thing. So if I say y equals 3, I can do something like x plus y. And it will do that, just like math. Same thing works for strings. I can say name equals Mark and age equals 22. And you can say things like name plus this plus age. Age is, there you go. And you can just substitute those strings in where they're supposed to be, right? Keep in mind that it wouldn't have worked this way if I had age as an integer instead of a string. I made a special point to keep that as a string. So variables are great, and we're going to use them everywhere. It's important to understand how the computer looks at variables so you know how they kind of float around in here and move, so to speak. So when you type in x equals 4 into the computer, what the computer is seeing on the inside is sort of like 2 boxes. You x, and you give it this variable, and you tell it 14, this number. What the computer is doing is it's relating x to this number 14, right? You can, and then when you do things like reassign x, when you say x equals 12, for instance, what the computer is doing here is it's taking a look at x, and it's like, oh, I already know something for x, but now we want it to be something different. We want it to be something different. And it just replaces that value in the box. Now it knows x is 12. And you could just as easily reassign it to a string. And it's going to replace that 12 with hello. Yeah. Now, this things can get sort of tricky here when you work with a few different variables. Say x equals 2, y equals 4, and let's set z equals y plus x. So now we've set up x, y, and z so that x is 2, y is 4, and z is actually equal to both of these values. So it's equal to 6, right? But you've got to be careful when you do stuff like this, because if you change x or y, it's going to change what z is. So we print out z, we get 6. Let's change x to 4. Now Python is still going to give me back 6, right? Even though I changed x. So it's not, Python works on like a static assignment system. But if I had changed x later and then came back and said z equals y plus x again, z is going to give me the 8. So you just got to be careful when you're working with these variables that you know where your numbers are coming from, you know how they're changing, so that as they go into each other, you know what you're getting out. And you guys sort of got used to this in Scratch when you were working with those angles and you had to switch up the angle at different parts, how your sides changed and your picture changed, all that jazz. You know that. But this is sort of how your computer sees variables. It's just linking this name to the actual value that it's storing in memory. Okay. What's next? Good. If you don't assign a variable, by the way, like if I type in A here, it's going to give you a name error because you haven't assigned A to anything. And when you make A equal to something, then it will know what A does. So if you get something like a name error, it means that it doesn't know what you're talking about yet, because you haven't assigned it to anything. In terms of the picture, you have an A sitting here, but it's not pointing anywhere. So Python doesn't know what to do with that. There's no value associated with your variable. That can happen a lot when variables go away on you, or the data that the variable's pointing at goes away, which can happen. Okay, next up, print. So we were talking about print a little bit earlier and what it does. So print, hello. Hello. So this looks almost identical to what was happening when we just typed in hello into the shell, but it's a little bit different. You'll see that it doesn't have the quotes around it anymore. And this is important because it's not, Python isn't giving us back a string anymore. It's not printing back to us a string. It's printing out, like literally printing out these characters on the line. It's a subtle but important distinction to make. For example, I can print out 42, and it prints out the characters 42. And it shows the same thing when I print out 42. It takes the string and prints out 42, and takes the int and prints out 42. To print, these are the same things. The same things at the end of the day. But basically what print does is it takes in some expression or some string or something, and it prints out sort of a logical display of those characters. This is it. So when we print, we can do print hello plus there. We get hello there. And we can do print number equals cluster of 42. Now this won't work if I try and do print number equals plus 42. And you'll see our error at the bottom. So somebody tell me what's the problem here. Yeah.
Can't mix integers and strings.
Exactly. Once again, we're running into type problems. It's trying to put together a string and an integer, and we just can't do that. So we have to convert the 42, the number we're trying to use, to a string first before we try and put it together with the string and print it out. Whereas if you just print out 42, it knows what to do because there's only an integer in there. So it knows like, oh, it's just a number in there. We'll just print out the number. No big deal there. Okay. Other things with print. You can put variables into print. Like I said before, variables just swap in and out. You can do print x comma y, and it will print out 4 and 4. This comma is sort of a special syntax just to tell Python print this and then that. I can also print x plus y, and it'll print out 8. We can print out stir x plus stir y, and it gives the 4 and then the 4. So the two characters put together. Pretty straightforward. Alrighty. Next up, and very important towards getting to what I was talking about in the beginning. We've sort of figured out how we can do math and how we can get those variables in place and how we can get all the types, the ints and the floats just right. Now, how can we start talking about if we want someone to give us data, we want to have some user put in data into Python. We can use the input keyword. Input takes in a string like, where are we? And it waits for the user to type in an answer. And I can type in my answer. And you see what input returns to us here is a string containing my answer, what I gave in there. Pretty neato. You can obviously put in numbers too. Let we're at 42. Wouldn't really be answering the question, but you can put in numbers on the input. But notice what it gives you back is a string. Input always returns a string. Even if the user puts in a number, a float, or an int, no matter what the user puts in, it always comes back to you as a string. Now, input is relatively useless right now because I asked where are we, but I can't do anything with it. I can't use it in my program anywhere right now. I can't, there's no way for me to grab it. So how do you think I can grab this input and use it later? Say I wanted to ask someone, where are we? And then I print out, we are here. And I want to print out what the user typed into me. I want to print out exactly what he typed into me. How can we grab this thing that the user gave into us? How can we store it? Anyone got an answer for that one? Say that again? How would you do that? Tell me. Let's call the variable place. And we type in Hendrix College. All right. Notice now that it doesn't give us a return this time. Throw the string back out at us. That's because we did a good job. We've actually stored that thing that the user typed into us into place. And when I type in place, I get back my Hendrix College. Great. So now I have this variable called place that I can use to say print we are at plus place. We're at Hendrix College. Turns out I didn't have to put the quotes around it because it just converts it to a string anyway. But it looks more like an official title, like we're at Hendrix College, so to speak. So this is how you take in input from a user. You ask for input and you store it as a variable. Let's do another example here. To ask the user what, we're going to multiply a number by 2. And we want to ask the user what number they want to multiply. So we want to get a number in from the user, and then we want to multiply it by 2 and print back the answer. So can someone get me started? Anyone, you can blurt out, I just want to, what do I need to type? Number equals. All right. Then we can put in something like 4. All right. So now, how are we going to print off this number? We want to print off something like your number times 2 is. So, do I start with a print statement? No. Is there something I have to do first? Let's start by looking at what number is. So this is what number is. And it's a string. So the first thing we need to do, right, is we need to multiply this number they gave us by 2. We need to do some math here on the number they gave us. We need to change it. So how about we set up another variable? What is new number going to be equal to? What was that? Number times 2. Okay. Let's check out what new number is. I don't think that's 4 times 2. Turns out strings know how to do multiplication too. It just multiplies the string after itself. So what do we have to do here? We need to treat this number, right now, number, our variable number is a string, right? But we want to do math with it. What do we have to do?
New number equals int number.
Perfect. We have to convert this number back to an integer. We know that the user gave us a number, like a number, not the word of a number. So we have to tell Python, look, this is not a string, trust us. It's an integer. And now we see new number 8. Perfect. Exactly what we want. So now we have our final results, and we can print plus what? Plus what?
That's the R number.
Clever. Because we got it to an int, new number is an int, now we have to convert it back to a string. Your number times 2 is 8. Perfect. So you can see the basic loop of input. You have to take in somebody's input. You have to grab that string. Maybe it is a string. Maybe it's a number. Maybe it's something else. You have to convert that to the type that you want it to be. Do your manipulation. Put it where you want it to. Maybe do some math. And then you can print the result back to the user. Just to finish up here, back to our original example of that whole equation, x equals all that stuff. You can ask the user, what is A? What is B? What is C? Convert those numbers to your integers, do the math on those numbers, and then print the result back to the user. Like your final result, x equals this. And we're going to be learning about how to script that up, how to actually write a whole program line by line to do that, instead of having this limitation of just being able to only write one command at a time. And we're going to be doing that next time. Oh, and the Drake equation. There's a word for you to Wikipedia. That's what we'll be looking at tomorrow. Ooh. Remember, the lab is due at 5 today. Make sure you turn that in. And yes, if you have any questions for me, anything like that, I'll be around on campus. You can email me at woodardmc@hendrix.edu. Dr. Godrich is still available for questions, all that jazz. So yeah, thanks for having me in class today. Yeah.
Enjoyed the class, Mark.
Oh, thank you.
But you're glad that you took Mr. Richardson's.
I know, right?
Yeah, comes in handy.
It's a little bit easier public speaking with computer science.
Yeah,
you always like, you have an excuse to look at this screen. I'm typing here.
Yeah, plus you're used to it, so
Yeah.
you know your area of expertise.
Mhm.
Well, you have a good day.
Yeah, you too.